Question 13 then, from the first paper in the 2014 National 5. Well, we've got a quadratic equation here. What does it say? This diagram shows the path of a small rocket which has been fired into the air. The height h after t seconds is given by this formula. So you could just write that as h equals, that's all it means really. How many seconds will it first be at a height of 60 metres? And there's 4 marks for that. Well, shouldn't be surprised because we've got to do something obviously. Well, there's a 60 to be substituted into this equation. Notice that equation, I'll just write it again with just h. H equals 16t minus t squared, because that just says h is a function of t, and it is because it only depends on t. So just writing it out with the bare variables. H is 16t minus t squared, 2 variables. You can find one of them if you know the other. So this time it's telling you the height 60. So I'm going to have 60 equals that. So 60 equals 16t minus t squared, and so I've got to find t. Well, there's 2 different mentions of t squared and t, so it's going to be a quadratic equation, so take everything over to one side. So the minus t squared will cross as t squared, the 16 will cross as minus 16, and the plus 60 was there already. So you have to solve that. So let's factorise it. It's a monic quadratic. That makes it particularly easy because I can just read it straight off of this. Knowing the pattern for a bracket times a bracket, the first times the first makes the first, so it must be a t times a t, if it factorises at all in paper 1. I know the last times the last makes 60, so these 2 numbers must multiply to give 60. And I know that the middle term is a 16 and it's formed by adding these 2 numbers, because these multiply to give a plus. Normally you just read it as this. Multiply to give 60. Well, there's loads of them. Quite often, as you start to write them out, you realise which ones are going to work, because it's got quite a few. Could it be 1 times 60, 2 times 30, 3 times 20, 4 times 15, it's getting closer together, 5 times 12, 6 times 10, now there's only 4 apart, so I've only got like 7, 8 and 9 to work, and they don't work. Now, out of all those possible pairs for the ones at the end, and quite often you don't need to write them out because it's obvious looking at it, I want the pair, because the signs have to be the same, that do this. Add to make 16. Forget that negative. Multiply to give 60, add to give 16. Which of them add to give 16? It's the 6 and the 10. So it must be the 6 and the 10. Who gets the negative? The 10 gets the negative. But, since they have to be the same, because normally it would work as the sign of the middle term goes to the bigger product out of the inner and outer product. So a negative in the middle means the 10 definitely gets the negative, but that says they're both going to get the same sign, so it gets it as well. So the answer to this is either when 2 things multiply to give 0, either this is 0, so forget that part, so t equals 6, or if that's 0, then solving that little bit, t equals 10. But, what did the question say? It says, after how many seconds will the rocket first be at a height of 60? Because notice there's 2 answers. So wherever those answers happen to be on it, when does it get to a height of 60 metres? It reaches it on the way up, it gets higher, and then it reaches it on the way down. So it must have taken 6 seconds to get there, and then after 10 seconds altogether it passed it on the way back down. So in this case the answer is t equals 6 seconds, because it has to be the first one. And the marks were substitute it in, that was 1 mark. Knowing to rearrange it, that's another one. Factorise it, and then finally getting the answers but selecting the correct one, not just leaving those 2. That would be the 4th one. Now there is another method, and the marking scheme does give answers for it, which is, if you're stuck, just use trial and error. Put 1 in, what'd you get for an answer? Put 2 in, what'd you get for an answer? Put 3 in, what'd you get for an answer? And eventually I found, put 6 in, and you'll get 60. If you're going to use trial and error, then you have to show several attempts at it. If you just said, oh, wait, 6 works, and said, right, if I put 6 in, then that comes to right about, that gives me 16 times 6 minus the 6 squared, which does in fact come to 60. If that's all you write, you'd only get 1 out of 4. because there's only the one attempt, you've not actually stated the answer. If you went on to say, well, t equals 6, that would give you 2 out of 4, because it's only one attempt. You have to put down, I think it's at least 2 attempts if you're going to do it by trial and error, if you're really stuck. But you shouldn't be, because that's an obvious question. It's a quadratic, it's factorise a quadratic. And so part B, for just 3 marks, there's probably more sort of explanation required here, because it says justify your answer. It says, will the rocket reach a height of 70? If that's 60, will it ever get to 70? Well, there's several ways you could continue with your trial and error if you wanted. You'd have to show all the different attempts. You know, try it at 6, then you go in for 7, 8, 9, 10. Then you notice they're getting smaller again. And then you could say, none of my answers have even reached 70. If that were the case, or maybe one of the answers went over 70, so you can say, yes, that is the case. But doing it properly, looking at this, from the previous one, you'd have also had the answer 10. That means you know that the maximum height must happen exactly halfway between the 6 and the 10, because the parabola's got an axis of symmetry. So it must happen at t equals halfway between the two, and I could show the working, add them and half them. It must happen at t equals 8. So that would be the first mark, knowing that the maximum height happens at 8. Now just find out what the height is. What is the height? What is the biggest height? It'll be 16 times 8 minus 8 squared. Notice that's like 2 times 8 times 8. So 2 lots of 8 squared. Take away an 8 squared, so the answer should just be 1 lot of 8 squared, so that should be 64 metres. But you could just work it out, you know, at the side, just like 8 sixes are 48, carry 4, 8 and 4 is 12, 8 squared 64, take it away, you can see it's double it, 64. Anyway, that would be a mark. And then making the statement, would it ever reach 70 metres? So the answer is no. But you can't just write no on its own. You'd have to put down a comparison, or they say an implied comparison. Like it only reaches, but you'd say no. The maximum height, this we have to put a writing, is 64 metres, and then stating the obvious, which is less than 70 metres, for instance. Or maybe you could abbreviate that part as maximum height is 64, and then just say 64 is less than 70, instead of writing the words. So that's the third mark. So, a second method, well, apart from trial and error, just going through them all and seeing that none of them reach 70, would be, because it didn't actually mention maximum height here, it's just take it as, well, let's try and find the time it took to get to 70. So in that case, we'd be solving that equation. Will it ever reach 70? Well, is there a solution for 70 equals 16t minus t squared? But certainly with a parabola, you'd have used your axis symmetry. And then try solving that. So t squared minus 16t plus 70 equals 0. I've got to solve that. And then you'd go through you'd try your factorisation. Multiply to give 70 and add to give 16. And as soon as you started that, you'd get stuck. You wouldn't be able to find anything. And the reason for that would be either the answers are decimals, so they'd have been hard to find in the first place. In other words, it wouldn't factorise to whole numbers. Or maybe there is no answer because it doesn't get there. And there's that other thing about a quadratic that lets you know about the answers, and that's the discriminant. So I'd have got that, and I've got scuppered trying to factorise it, because it is just paper 1. I'm not going to use my formula, because I only need one part of the formula. Remember, the formula would be, I know it says t, would be t equals, it would be negative b plus or minus the square root of b squared minus 4ac all over 2a. I'd have to put those numbers into it, but then I've got this square root and so on. How am I going to do that in paper 1? Because if the square root worked, it would have factorised in the first place. But you don't need to, because it's just this part here that matters. If that part's negative, there are no answers. If that part's not negative, there will be an answer, which won't matter because the question didn't ask for it. It just said, will it ever get to 70? So this will tell you. So I could say, well, what's b squared minus 4ac? Well, that would equal negative 16 squared, just the coefficients, minus 4 times the coefficient of t squared is 1, times 70. But a calculation here, unfortunately, well, this bit's not too bad. That's minus 280. 16 squared, you might do that all sorts of different ways. By the time you do, I'll just put it down to the side. You might know 16 squared. That'd be quite good. 6 sixes are 36, 3 over 96, and a 16 is 256. That's a negative number. So now you can say, if that had been a positive number, the square root in the formula would be the square root of a positive number, so there would have been answers. If that's a negative number, the square root in the formula, this is the discriminant, the square root in the formula would have been the square root of a negative number, which wouldn't have had any real answers, so that means there wouldn't have been a height that worked. So I can make this statement, b squared minus 4ac, because I've got that, is less than 0, which means there's no real roots. Probably have to write it down in that form. For instance, it's got no real roots, which means it does not reach 70 metres. That might seem a bit more sophisticated, forming the equation and then demonstrating that this equation has no answers by taking its discriminant. But I still think the better method was just to use the symmetry in the curve and find the highest point and then just show that it never actually reached 70. So the 3 marks were, obviously got the communication mark was one of them. So one of the marks was for showing that that discriminant was less than 0, and the other one was for the evidence of using the discriminant somewhere round about here.